When is a case where the quadratic function ax squared plus bx plus c is greater than 0 in terms of x value. And there's some choices, 3 choices that we can choose. And before we solve for this question, let's think about our solutions for this question. At first, they said when we're going to be the case where where the quadratic function ax squared plus bx plus c is greater than 0 in terms of x value. So when you think about the cases that quadratic function's x value can be always greater than 0. And secondly, we need to think about situations for using discriminant. And we can talk about later while solving this question. Before we solve for this question, let's think about what is the function of a. So for the a, first of all, for the a value, it is a thing that defines the type of the function, which means when the a value is greater than 0, which means when the a value is equal to positive, the graph will go upward. When the graph goes upward, it will look something like this, that goes upward, that goes toward upward, and then only a minimum point will exist. Let's think about the second example. So the second case is a case when the a value is less than 0. When the a value is less than 0, the graph will go downward. When the graph goes downward, that means the graph is going toward the down, which will look something like this, but then only the maximum point will going to exist in the function. And this is what the a does. It defines the type of the function. But for the minimum and maximum point, they can be a points that can be lowest or the maximum, where it can be defined by the a value. If we add minimum and maximum cases, we'll call it as vertex of the function. For the a value, if you look at our choices, all of them are greater than 0. So the a value is greater than 0 in this case, which means the graph will satisfy the first one where the graph will go the upward. So the graph will look something like this, and it only contains a minimum point as its vertex. But if you look at our second one where it says b squared minus 4ac, it's the case where we need to use our discriminant equation. And for a discriminant equation, it is formed by negative b plus or minus square root of b squared minus 4ac over 2a. And this we call it as discriminant because it is where we use it. We use this for finding the solutions of functions or equations. And the way we put it is in this way. So inside the square root is the most important thing because it defines how many solutions there is. So when the square root, we can just call it as SQ, which stands for square root inside the square root. When the value inside the square root is greater than 0, so we can write it down on the top of it. When the square root value is greater than 0, there will going to be 2 solutions. And the reason why we're using this is because when this is hard to find solutions because of, let's say, it's hard examples to solve it when it is also decimal or fraction. We're just trying to see how many solutions there are and how many solutions there exist. When it's inside the square root value is greater than 0, there will going to be 2 solutions. The reason is because it is negative b plus or minus square root of b squared minus 4ac over 2a. And when the square root inside of square root is greater than 0, so when this is greater than 0, the reason why there's two solutions is because there are going to be two cases where negative b plus square root inside over 2a. There's also the case of minus, which will going to be negative b minus square root inside over 2a. So that's why when the inside the square root value is greater than 0, there will going to be two cases for total. Let's think about the other cases. And when the square root inside is equal to 0, then it will going to be negative b plus or minus square root of 0 over 2a, which will only contains a 1 solution. The reason why it only contains one solution is because if it's just a square root of 0, even though we apply plus or minus, this won't affect our original function because it's still 0. So the only solution that we have in here will going to be when the square root inside is equal to 0, it will going to be negative b over 2a. This is our solution when the square root inside is equal to 0. And for the last case, it is a case when the square root inside the square root is less than 0. When the square is less than 0, we call it no solution. The reason is because less than negative b plus or minus square root of, for example, negative 1, there is no thing that can be squared by the negative numbers. So we call it into a imaginary number where it doesn't exist. So we can apply our three situations to this question since we saw b squared minus 4ac. B squared minus 4ac is a things that they're located inside the square form. And in terms of x value, which means we know the function is a case where it is the relation between x and y value. In terms of x value, there should be always greater than 0, which means y should be always greater than 0 according to our function property. Which means, according to our function, there can be no x-intercept. The reason is because the y value should always be greater than 0, but for the x-intercept, it is a case where the x value exists and the y value is equal to 0. But when the y value is equal to 0, it doesn't satisfy our purpose or our suggestion from the question. So we can have a x-intercept, and the graph should satisfy our upward direction. If we say this is an x-axis, the graph would look something like this that goes straight upward that only contains a minimum point, which satisfies our first case when the a value is greater than 0, the graph goes upward. And that it won't contain a x-intercept according to our property here, that y value should always be equal to 0 according to our function property, and there can be an x-intercept because x-intercept means x value exists and the y value is equal to 0. Solution, where it says solution, the solutions mean is a case when the y value is equal to 0 and the x value exists, which means it's the same thing with x comma y, but the y value is equal to 0. The reason why we're trying to find solutions is because we're trying to find the x value when the y value is equal to 0. And solution is the same thing with our concept of this form of discriminant, because if there's two solutions, that means there will going to be two solutions, such as, for example, x minus 3 and then x plus 2, for example, where the x value is equal to 3 and then 2. And for the one solution, that means only one solution exists. For example, y is equal to x plus 1, where the x value is equal to -1. But our function cannot satisfy both of these because if there's any solution, that means it passes through our x-axis, because solution means when the y value is equal to 0, the x value exists. But this graph cannot pass through the cannot pass to the x-axis um, to show that this function satisfies our one of the purpose here. So this case, for here, there can be a solution exist. There can be a solution exist, which means for the first case where two solution exists, it doesn't make sense. For the second one where the one solution exists, it doesn't satisfy requirements. But for the last one, when the square root inside the square root, which was b squared minus 4ac, it is no solution. It makes sense because if there's no solution, if there's no solution exists, that means no solution. So our function here satisfy b squared minus 4ac should be less than 0, where there is no solution exists, and we call it imaginary number. So our answer for this question where the case where the quadratic function x squared plus bx plus c squared is 0 in terms of x, our answer for this question will going to be 3, where the a value is greater than 0, which means the graph goes operate only the minimum point exists. B squared minus 4ac, which is a numbers inside the radical, and then that should be less than 0, so that it requires our function that it cannot contain any solutions for this function.